Hi, and welcome to this Now Maths video on solving linear simultaneous equations. This video will be perfect for you if you're either just getting started with linear simultaneous equations or feel like you need lots of help with this topic. If you would like a shorter recap on this topic, please find our Revise Now video linked below. Now let's get started. So first of all, what does it mean for an equation to be linear? All of the equations on screen right now are linear. They all have a single variable or unknown in them, and they can all be solved to find out the value of this unknown. There are also no powers greater than 1 in them, so we can't see any squared or cubed terms, for example, and there are also no unknowns being multiplied together, so we can't see any xy's or anything like that. So if they're all linear equations, what are linear simultaneous equations? Well, let's have a look. This equation here is another linear equation, since there are no powers greater than 1 and there are no unknowns being multiplied together. It looks a little different from the ones on the other screen because this one has two variables. We have both an x and a y. Equations like this can still be solved, and actually this equation here has an infinite number of values of x and y that would satisfy it. In order for this equation to have just one solution, we need to introduce a second equation that x and y must also satisfy. And if we have two equations like this, these are called linear simultaneous equations, and there is only one value of x and one value of y that could satisfy both equations at once. So how do we solve these equations? We could try different values of x and y until we find a pair that work, but this could be quite time consuming. So in this video we're going to look at the method of elimination to solve simultaneous equations. So let's take a look at the two equations from before and see if we can try and find a solution. These two equations here have a common term in them. This 2y term is common to both equations. So we're going to try and eliminate this term. And what we're going to do to eliminate the term is we're going to subtract one of the equations from the other. And to do that, we're going to subtract each term separately. So we're going to do 5x subtract 1x, which is 4x. Then 2y subtract 2y is 0, which I'm actually not going to write. I'm going to carry the equals sign down, and then 16 subtract 8 is 8. So we're now left with a nice linear equation that we can solve, which is 4x equals 8. To solve this for x, we divide by 4, and when we divide by 4, we get x on the left, and 8 divided by 4 gives us 2 on the right. So our x solution is x equals 2. Now we need to use this x value to find the correct value of y. To do this, we're going to substitute this value into one of the equations that we first started with. It doesn't matter which of the equations we select, however usually I would recommend substituting into the equation with the smallest numbers or the most positive numbers. Since all of our numbers here are positive, I'm going to choose to substitute our x value into the equation with the smallest numbers, which in this case is the second equation. So as part of our working out, we're going to write that we will substitute our value of x equals 2 into our chosen equation, which is x add 2y equals 8. Now when we substitute x for 2, the x is replaced with 2, so our equation becomes 2 add 2y equals 8. We're now left with another nice linear equation to solve. This time there is just a y in this equation. So to solve this, we're going to subtract the 2 from each side. So on the left hand side, we are left with just 2y. And on the right hand side, 8 subtract 2 is 6. And then if we're left with 2y equals 6, we divide by 2. and this should give us y on the left, and 6 divided by 2 is 3 on the right. So our y solution is y equals 3. When solving simultaneous equations, the last thing that we need to do is write our solution as a pair. So our pair is x equals 2 and y equals 3. And we write that at the end together. So x equals 2 and y equals 3. Now let's have a look at another pair of similar simultaneous equations. This time, if we look at both equations, we can see that we have again a common term, which this time is the 4x term. And again, to eliminate this term, we're going to subtract one of the equations from the other. So subtracting each term separately, we're going to do 4x subtract 4x first, which is 0, so we won't write that down. Then we're going to do 5y subtract 3y, which is 2y. And then we're going to do 44 subtract 28, which is 16. We're left with a nice linear equation that we can solve. This one this time is in terms of y, and if we have 2y, we're going to divide by 2, which should give us y on the left, and 16 divided by 2 gives us 8 on the right. So our y solution is y equals 8. So this time we've found our value of y first, and we now need to use this value to find the correct value of x. And again, we're going to substitute this value into one of the two equations that we started with. Given that the bottom equation has got slightly smaller numbers, I'm going to choose to substitute into the bottom equation. However, it does not matter which one you select. So for our working out, we write that we are going to substitute y equals 8 into our chosen equation, which this time is 4x add 3y equals 28. And when we substitute y for 8, the y is replaced with 8, so our equation becomes 4x add 3y will become 3 times 8 equals 28. And then this time we're going to need to calculate the value of 3 times 8. 3 times 8 is 24, so we will have 4x add 24 equals 28. And we're left with a linear equation only in terms of x now. So we're going to subtract the positive 24 from both sides, which should give us 4x on the left, and on the right, 28 subtract 24 is 4, and we're then going to divide by 4, which should give us x on the left, and on the right, 4 divided by 4 is 1. So we have an x solution of x equals 1. Then the final thing we need to do to complete this question is to write our solution as a pair. Usually the x value is written first, so we have x equals 1 and y equals 8. So we write that down at the end. Let's have a look at another pair of similar simultaneous equations. So for this pair here, we can see that we have our common term in each, which is the 3y term. So we're going to need to subtract one equation from the other in order to eliminate this. If we take a look at these equations, if we were to start subtracting these, 2x subtract 7x would give us negative 5x. This isn't a problem, however, usually when this happens, I would recommend swapping the order of the two equations. So I'm going to rewrite this except with the 7x plus 3y equals 55 first, and the 2x, add 3y equals 35 second. Now if we subtract these, hopefully we can avoid using negative numbers. And the only reason I usually avoid the negative numbers is because it minimises our chances of making a mistake. So starting off with 7x subtract 2x, this gives us 5x. Then 3y subtract 3y is 0, so we won't write that down. We'll carry our equals sign, and then 55 subtract 35 is 20. So we're left with 5x equals 20. So to solve, we divide by 5. And when we divide by 5, we end up with x on the left. And on the right, 20 divided by 5 is 4. So our x solution is x equals 4. We now need to use this x value to find the corresponding value of y. So we're going to substitute this value into one of the equations we started with. In this case, I'm going to choose to substitute into the top equation because this equation has the smaller numbers. So we write that we will substitute x equals 4 into 2x plus 3y equals 35. And this time we are replacing x with 4. So 2x becomes 2 multiplied by 4. And then we have plus 3y equals 35. Now we can calculate the value of 2 multiplied by 4, which is 8. So we can rewrite this as 8 add 3y equals 35. We now have our linear equation with just y in it. So to solve, we're going to subtract the positive 8 from each side. So on the left-hand side, we have just 3y. And on the right-hand side, 35 subtract 8 is 27. Now we have 3y equals 27, so we divide by 3, which gives us y on the left, and on the right, 27 divided by 3 is 9. So we have our y solution of y equals 9. And the only thing left to do is write our solution as a pair, so we have x equals 4 and y equals 9. Now you've seen a few pairs of simultaneous equations, you might want to take this opportunity to pause the video and have a go at a couple of questions for yourself. When you're ready to see some solutions, press play. If you paused the video, welcome back. Let's have a look at some solutions. So for our first pair of simultaneous equations, we have a common term of 3y in each of our equations. So we're going to subtract one equation from the other. So starting with 5x subtract 2x, we have 3x. 3y subtract 3y is 0. And 23 subtract 20 is 3. Now we're left with 3x equals 3. We divide by 3. And this gives us x on the left. And 3 divided by 3 is 1 on the right. So our x solution is x equals 1. Now we've found our x solution, we have to go back and substitute to find the y solution. I would choose to substitute into the second equation here because the numbers are smaller. So we would write that we're going to substitute x equals 1 into 2x plus 3y equals 20, and x is being replaced with 1. So our 2x would be 2 multiplied by 1, which we could write as 2. And we would have our add 3y equals 20. We now solve this linear equation by subtracting the positive 2, which leaves us with 3y on the left, and on the right, 20 subtract 2 is 18. We then divide by 3, which gives us y on the left, and 18 divided by 3 is 6. So our final solution is x equals 1 and y equals 6, which we write as a pair. Now taking a look at the second pair of equations, we can see that we have our common term of 5x in each, so we're going to subtract one equation from the other. Given that the numbers in the second equation are larger than the numbers in the first, we're going to get some negative numbers if we subtract them as they are. So I would choose to swap the order of the two equations to make them easier to subtract. Now we've rewritten the equations, we're going to subtract the second equation from the first. So starting off with 5x subtract 5x is 0, so we won't write that down. 5y subtract 3y is 2y. And finally, 45 subtract 35 is 10. So to solve 2y equals 10, we divide by 2. And this gives us y on the left, and 10 divided by 2 is 5 on the right. So we have our y solution first this time. We're now going to substitute this value of y equals 5 into either of the equations we started with. Given that the top equation has smaller numbers, I would choose to substitute into this one. So we would write that we're going to substitute y equals 5 into 5x add 3y equals 35. And when we substitute y for 5, we end up with 5x add 3y would become 3 multiplied by 5, which is 15, equals 35. And now we solve our linear equation. We subtract the positive 15 from each side, which will give us 5x on the left, and 35 subtract 15 gives us 20 on the right. We then divide by 5 to give us x on the left, and on the right, 20 divided by 5 is 4. So we have an x solution of 4. So our final solution pair is x equals 4 and y equals 5, which we write together. Now we're going to have a look at another slightly different looking pair of simultaneous equations. Looking at this pair, we can see that we've got two terms which look almost identical, except one of the terms is negative 2y and the other is a positive 2y. Now let's see what happens if we try and subtract these equations. So starting off, we're going to do 5x subtract 3x, which is 2x. Then we're going to do negative 2y subtract positive 2y. If we subtract another 2y from negative 2y, we get negative 4y. And finally, 18 subtract 14 is 4. So this time we can see that subtracting these equations hasn't been helpful because we've still got an equation that has both an x and a y in it, so we haven't made anything any easier to solve. We're going to have to approach questions like this slightly differently. So to solve these equations, we're going to use the fact that if we add 2y to negative 2y, we get 0. So if we were to add these equations together, we would eliminate the 2y term entirely. Because we're adding, the order of the equations doesn't matter at all this time. So starting with 5x add 3x, we get 8x. Then negative 2y add positive 2y is 0, so we won't write that down. And finally, 18 add 14 is 32. Now we're left with 8x equals 32, so we have eliminated the y term, and we solve by dividing by 8. So we end up with x on the left, and 32 divided by 8 is 4 on the right. So our x solution is x equals 4. Now we've found our value of x, we need to use this value to find the value of y. and I'm going to choose to substitute into the second equation this time, as the numbers are smaller and all of the numbers are positive. So we will write that we will substitute x equals 4 into our chosen equation, which is 3x add 2y equals 14. And if we're substituting x for 4, that means that x becomes 4. So 3x is 3 multiplied by 4, which is 12. And we have add 2y equals 14. We now solve this equation. We subtract the positive 12 from each side. So on the left we have just 2y, and on the right 14 subtract 12 is 2. Finally we divide by 2, which gives us y on the left, and 2 divided by 2 is 1 on the right. So our final solution is that x equals 4 and y equals 1. So let's have a look at another pair of simultaneous equations that are similar. We can see this time we have a 4x in each, where 1 is positive and 1 is negative. So we're going to use the fact that if we add these two terms together, we'll get an answer of 0, so we'll eliminate that term. So just to check, 4x add negative 4x is 0, so we don't write it down. 5y add 7y is 12y. And finally, 42 add 30 is 72. We then divide by 12 to give us y on the left, and 72 divided by 2 is 6. So our y solution is y equals 6. We now use this y value to find our matching x value. And this time I'm going to choose to substitute into the top equation, given that all of the numbers are positive, so we're less likely to make a mistake. So we write that we're going to substitute y equals 6 into 4x add 5y equals 42, and when we make our substitution of y for 6, we would write 4x and 5y becomes 5 multiplied by 6, which is 30, equals 42. And then solving for x, we subtract the 30 from both sides to give us 4x on the left and 12 on the right. And then dividing by 4 gives us x on the left and 3 on the right. So we have our x solution as x equals 3. So our final pair is x equals 3 and y equals 6. Now you've seen a couple of questions like this, you might want to use this opportunity to pause the video and have a go for yourself. When you're ready, press play to see the solutions. Now let's have a look at some solutions. So for our first pair of simultaneous equations, we can see we have a term of 7x in each, where one is positive and the other is negative. So in this case, we add the two equations together to eliminate the x. And when we add these equations together, 7x add negative 7x is 0, 3y add 2y is 5y, and 31 add 9 is 40. So we're left with 5y equals 40, which we can solve by dividing by 5 to give us y equals 8. We now substitute this value into one of the two equations we started with, and given that the top equation has all positive numbers, I would choose to substitute into this one. So we're substituting y equals 8 into 7x add 3y equals 31. So the y is being replaced with 8, which gives us an equation of 7x. 3y becomes 3 multiplied by 8, which is 24, equals 31. We then solve by subtracting 24 from each side, which gives us 7x on the left and 7 on the right. and then dividing by 7 gives us our solution of x equals 1. So we have a solution pair of x equals 1 and y equals 8. Now looking at our second pair of equations, we can see again that we have a similar term in each, where one is a negative 4y and the other is positive. So to eliminate these terms, we need to add the two equations together. So this time 3x add 7x is 10x. Negative 4y add positive 4y is 0. And 7 add 43 is 50. We then solve by dividing by 10, which gives us an x solution of x equals 5. We now substitute this back into one of the equations we started with, and given that there are no negative numbers in the second equation, I would choose that equation to substitute into. So we are substituting x equals 5 into 7x add 4y equals 43. So when we substitute x for 5, 7x becomes 7 multiplied by 5, which is 35. Then we have add 4y equals 43. We now solve this equation by subtracting 35 to give us 4y on the left equals 8 on the right, and then dividing by 4 gives us y on the left and 2 on the right. So we have a y solution of y equals 2. So our final answer is x equals 5 and y equals 2. Now we've seen two different types of simultaneous equations, some where we need to add and some where we need to subtract. You might be thinking, well, how do I know whether to add or subtract? So let's have a little look. For the first question on the screen, we can see we have a common term of 3y in each of our equations. Both of the terms are positive, and when this happens, to eliminate this term, we need to subtract, because 7x subtract 5x would give us 2x, 3y subtract 3y gives us 0, which we don't write down, and then 47 subtract 37 gives us 10. So we've ended up with a linear equation where we've eliminated the y variable altogether, and we could go on to solve the equations from here. Now looking at the second pair of equations on screen, this time we have a 3x term in each. However, one of the terms is negative and the other term is positive. When this happens, we add the two equations together. So let's just check it works. Negative 3x add positive 3x is 0, so we don't write that down. 3y add 2y is 5y. And 15 add 20 is 35. So we now have a linear equation where we've eliminated the x variable and we could solve the equations from here. For the third pair of equations on screen, similar to the last pair, we have two terms which look similar. However, one of the terms is a positive 2y and the other is a negative 2y. When this happens, we add the two equations together, and let's just check. 6x add 5x is 11x. 2y add negative 2y gives us 0, because if you add a negative it's the same as subtracting. And 16 add 6 is 22. So we're left with 11x equals 22, which is a linear equation where the y has been eliminated. And for our final pair of equations on screen, we have our common terms of 5x, both of which are positive this time, which means that we have to subtract the equations to eliminate this term. So just checking, 5x subtract 5x is 0, which we don't write. Then we have 2y subtract negative 3y. If we subtract a negative number, we add it, so this is the same as 2y add 3y, which is 5y. And finally, 37 subtract 32 is 5. So again, we're left with an equation where we've eliminated the x term and we could solve this to find out the solutions to the equations. Now let's take a look at a different kind of simultaneous equations. So the equations on screen right now don't have a common term in them. So what we're going to do is we're going to try and make it so that we can eliminate one of the variables. So first of all, if we take a look at the x coefficients, or the numbers in front of the x's, we have 5 and 10. 5 is a factor of 10 because 5 goes into 10. Now let's take a look at the y coefficients, or the numbers in front of the y's. 2 is not a factor of 7. To help us in this question, we're going to use the fact that 5x multiplied by 2 is 10x. So what we're going to do is we're going to multiply the top equation by 2. And as long as we multiply the entire equation by 2, we're not changing the solutions at all. So multiplying the entire equation by 2. 5x multiplied by 2 is 10x. Then 2y multiplied by 2 is 4y. And finally, 19 multiplied by 2 is 38. So now, looking at this equation and the one above, we have a 10x in each, and they are both positive. So if we were to subtract the bottom equation from the top, we would end up eliminating the x term. So let's try. 10x subtract 10x is 0, so we won't write that down. 7y subtract 4y is 3y. And 44 subtract 38 is 6. So we're left with 3y equals 6, and we can now solve this by dividing by 3 to give us y equals 2. When we've found one value, the rest of the method is exactly the same as previously. So we're going to make a substitution that will allow us to work out the x value. In this case, I'm going to choose to substitute into the top equation because the numbers are smaller. So now when we make our substitution of y for 2, we write down 5x, 2y becomes 2 multiplied by 2, which is 4, equals 19. And then solving, we subtract 4 from each side to give us 5x equals 15. And we divide by 5 to give us x equals 3. So our final solution is that x equals 3 and y equals 2. Now we're going to have a look at another similar pair of simultaneous equations. So this time, looking at the coefficients of x, we have 2 and 5. 2 is not a factor of 5. So let's look at the coefficients of y. We have 3 and 9. 3 is a factor of 9, and if we multiply 3y by 3, we would get 9y. So we're going to multiply the entire equation by 3. And again, as long as we multiply the entire equation by 3, we're not changing the solutions. So 2x multiplied by 3 would give us 6x. Then negative 3y multiplied by 3 is negative 9y. And finally, 13 multiplied by 3 is 39. Now if we take a look at this equation and the one directly above it, we can see that we've got a 9y term in each, where one is positive and the other is negative. To be able to eliminate these, we need to add the equations together. So adding together 5x and 6x, we get 11x. Then 9y add negative 9y is 0. And 16 add 39 is 55. Now we solve by dividing by 11. which gives us an x solution of x equals 5. We now substitute this value back into one of the equations that we started with, and for this set I'm going to choose to substitute into the second equation because the numbers are all positive. So we're substituting x equals 5 into 5x add 9y equals 16. So when we replace x with 5, 5x becomes 5 multiplied by 5, which is 25. Add 9y equals 16. And then to solve, we subtract 25 from each side, which gives us 9y on the left, and being careful on the right, 16 subtract 25 gives us negative 9. Then dividing by 9, we have y on the left and negative 1 on the right. So our final solution is x equals 5 and y equals negative 1. Now you've seen a couple of examples of equations that need multiplying first, you might want to pause the video here and have a go at this for yourself. Come back when you're ready to see some solutions. If you paused, welcome back. Let's have a look at some answers. So for our first pair of equations, if we look at the coefficients of x, 4 is not a factor of 6. If we look at the coefficients of y, one of them is a 5y and the other is a 1y. 1 is a factor of 5, and if we multiply y by 5, we get 5y. So we're going to multiply the entire bottom equation by 5. So starting off with 4x multiplied by 5, which is 20x. Then y multiplied by 5 is 5y. And finally, 11 multiplied by 5 is 55. Now we have this equation at the bottom and this equation at the top that both have a 5y in them. To be able to use these two equations, I'm going to rewrite the top equation just underneath the equation we've just written. Now the 5y's in both of these equations are both positive, so to eliminate the 5y, we're going to subtract the equations. So 20x subtract 6x gives us 14x. 5y subtract 5y is 0, and 55 subtract 27 is 28. And then solving this equation by dividing by 14 gives us an x solution of 2. And now we need to substitute this solution into one of the equations we started with. In this case, I would choose to substitute into the bottom equation. So when we substitute x for 2, 4x becomes 4 multiplied by 2, which is 8. Add y equals 11. And then to solve this equation, subtracting 8 from each side gives us that y equals 3. So our final answer is x equals 2 and y equals 3. Now looking at our second pair of equations, looking at the x coefficients first, 3 is not a factor of 5. Looking at the y coefficients, 4 is a factor of 8, and 4 multiplied by 2 would give us 8. So we're going to multiply the entire top equation by 2. And when we multiply by 2, 3x multiplied by 2 is 6x. Negative 4y multiplied by 2 is negative 8y. And finally, 2 multiplied by 2 is 4. Now looking at this equation and the one directly above it, we have an 8y in each, where one is positive, the other is negative. In this case, to eliminate this variable, we have to add the equations together. So 5x add 6x gives us 11x. 8y add negative 8y gives us 0, and 62 add 4 gives us 66. Then solving this equation by dividing by 11 gives us an x solution of 6, We now substitute this value back into one of the equations we started with, and I'm going to opt to substitute into the bottom equation where all of the numbers are positive. So when we replace x with 6, 5x becomes 5 multiplied by 6, which is 30. And we have add 8y equals 62. And then we solve by subtracting 30 from each side to give us 8y equals 32. And then dividing by 8 gives us that y equals 4. So our final answer is that x equals 6 and y equals 4. Now we're going to look at some slightly different simultaneous equations again. This time, if we start by looking at the x coefficients, we can see that 3 is not a factor of 5. If we look at the y coefficients, 4 is not a factor of 7. This means there is no whole number that we can multiply either of these equations by to eliminate one of the variables. So to solve a problem like this, we're going to look at lowest common multiples. So to begin with, looking at the x coefficients of 3 and 5, the lowest common multiple of 3 and 5 is 15, because that's the lowest number that both 3 and 5 go into. Looking at the y coefficients of 4 and 7, the lowest common multiple of 4 and 7 is 28, because again, this is the lowest number that both 4 and 7 go into. Out of the two, 15 is lower, so I'm going to choose to make the x coefficients both into 15. We could make the y coefficients both into 28, but usually I would choose the lower of the two numbers to minimise our chances of making a mistake. So looking at the first equation first, if we want to make 3x into 15x, we're going to have to multiply this equation by 5. So multiplying each term by 5, 3x multiplied by 5 is 15x. Then 7y multiplied by 5 is 35y. And finally, 24 multiplied by 5 is 120. Now looking at the second equation, to make this 5x into 15x, we're going to have to multiply by 3. So multiplying all of the terms by 3, 5x multiplied by 3 is 15x. 4y multiplied by 3 is 12y. And finally, 17 multiplied by 3 is 51. Now we have two equations with a 15x in both, and because they're both positive 15x, we need to subtract one equation from the other in order to eliminate that variable. So 15x subtract 15x is 0, 35y subtract 12y is 23y, and 120 subtract 51 is 69. Now solving the linear equation by dividing by 23, we get y equals 3. Now exactly the same as previous questions, we're going to substitute into one of the equations we started with. I'm going to choose to substitute into the second equation because there are some slightly smaller numbers. So now substituting y for 3, we end up with 5x. 4y becomes 4 multiplied by 3, which is 12, equals 17. And then solving for x, we subtract 12 to give 5x equals 5. And then dividing by 5 gives us a solution of x equals 1. So our final answer is x equals 1 and y equals 3. Now looking at another similar question. So if we look at the x coefficients, 3 is not a factor of 5, And similarly for the y coefficients, 3 is not a factor of 4. So we're going to take a look at the lowest common multiples again. So looking at the coefficients of x first, which are 5 and 3, the lowest common multiple of 5 and 3 is 15, because that's the lowest number that 5 and 3 both go into. Then similarly, looking at the lowest common multiple of the y coefficients, which are 3 and -4, the lowest common multiple is 12. And this tells us that we could make either the x coefficients both into 15 or the y coefficients both into 12. Since 12 is lower, I'm going to choose to make the y coefficients both into 12. And we won't worry about the fact that one is positive and one is negative for now. So looking at the first equation, if we want to make our 3y into 12y, we're going to have to multiply the equation by 4. So multiplying by 4, 5x multiplied by 4 is 20x. Then 3y multiplied by 4 is 12y. And -29 multiplied by 4 is -116. Now looking at the second equation, if we want to make our 4y into 12y, we're going to have to multiply this equation by 3. So multiplying each of the terms by 3, 3x multiplied by 3 is 9x. Then -4y multiplied by 3 is -12y. And 29 multiplied by 3 is 87. Now we have both equations with a 12y, where one is positive and the other is negative. So that means we have to add the two equations together. So 20x add 9x makes 29x. 12y add -12y is 0. And -116 add 87 is -29. And solving this equation by dividing by 29 gives us a solution of x equals -1. We're now going to substitute this back into one of the two equations that we started with. It doesn't matter which, and given that both have similar sized numbers and negative numbers in each, it's not going to make too much difference this time. I'm going to choose to substitute into the second equation here. So we are replacing x with -1. So 3x becomes 3 multiplied by -1, which is -3. Subtract 4y equals 29. Then when we solve this, because we have a -3, we have to add 3 to both sides, which gives us -4y equals +32. And then we have to divide by -4 to give us y equals, and 32 divided by -4 is -8. So when we have negative solutions, we do have to be a little bit more careful with our method. And our final answer is x equals -1 and y equals -8. Now for our final example in this video, we have another similar question. So looking at the coefficients of x, 3 is not a factor of 7, and the coefficients of y, 3 is also not a factor of 5. So we're going to look at the lowest common multiples first. So looking at the x coefficients, 3 and 7 have a lowest common multiple of 21. And looking at the y coefficients, ignoring the fact they're both negative, 3 and 5 have a lowest common multiple of 15. Since 15 is smaller, I'm going to choose to make the y coefficients both 15. Now starting off with the first equation, to make 3y into 15y, we're going to have to multiply by 5. So 3x multiplied by 5 is 15x. Negative 3y multiplied by 5 is negative 15y. And 24 multiplied by 5 is 120. Now looking at the second equation, if we want to make 5y into 15y, we have to multiply by 3. So multiplying by 3, we have 7x multiplied by 3 is 21x. Then negative 5y multiplied by 3 is negative 15y. And 50 multiplied by 3 is 150. Now if we have a look, we have a 15y in each, and both are negative, so we subtract the equations, because negative 15y subtract negative 15y is the same as negative 15y add 15y, which gives us 0. So subtracting, we have 15x subtract 21x, which is negative 6x. Then negative 15y subtract negative 15y is 0. And then 120 subtract 150 is negative 30. Of course, if you wanted to swap the order of those equations before subtracting to avoid the negative numbers, you absolutely could. Now solving, we're going to have to divide by negative 6, which gives us x on the left, and negative 30 divided by negative 6 gives us positive 5. So our x solution is positive 5. Similar to the last question, when we substitute this back into one of the equations, neither of them are all positive, so I'm going to choose to substitute into the one with the lower numbers, which is the top equation. So we are substituting x for 5, so 3x becomes 3 multiplied by 5, which is 15, and we have subtract 3y equals 24. And then solving, we subtract our positive 15 from both sides to give us negative 3y on the left and 9 on the right. Then dividing by negative 3, we have y on the left, and 9 divided by negative 3 is negative 3 on the right. So our final answer is x equals 5 and y equals negative 3. Now for the final time in this video, if you would like to check your understanding of these questions, please pause the video now and have a go at the questions on screen. Come back when you're ready to see some solutions. If you paused the video, welcome back. Now let's have a look at some solutions. So both of these questions will require us to look at lowest common multiples. So looking at the coefficients of x first, 4 and 5 have a lowest common multiple of 20. And the coefficients of y, 3 and 2, have a lowest common multiple of 6. So I'm going to choose to make the y coefficients 6 because that's smaller. If we're going to make 3y into 6y, we're going to have to multiply this first equation by 2. So multiplying the first equation by 2, 4x multiplied by 2 is 8x. Then negative 3y multiplied by 2 is negative 6y. And 14 multiplied by 2 is 28. Now for the second equation, if we're going to make 2y into 6y, we're going to have to multiply by 3. So 5x multiplied by 3 is 15x. Then 2y multiplied by 3 is 6y. And finally, 29 multiplied by 3 is 87. Now we have two equations with a 6y in each. One is negative and the other is positive, so that means we're going to have to add the equations together. So starting off with 8x add 15x gives us 23x. Negative 6y add 6y is 0. And 28 add 87 is 115. Then to solve this, we divide by 23. to give us a solution of x equals 5. We now substitute this into one of the equations we started with, and I'm going to choose to substitute into the second equation because that's all positive. So replacing x with 5, 5x becomes 5 multiplied by 5, which is 25, and we have add 2y equals 29, and then solving we subtract 25 from each side to give us 2y equals 4, and then dividing by 2 we have a y solution of y equals 2. So our final answer is x equals 5 and y equals 2. Now if we take a look at the second question, if we look at the x coefficients, 4 and 5 have a lowest common multiple of 20, and 2 and 7 have a lowest common multiple of 14. Since 14 is lower, we're going to try and make the y coefficients into 14. If we are going to make 2y into 14y, we'll have to multiply the top equation by 7, and when we multiply by 7, 5x multiplied by 7 is 35x, then 2y multiplied by 7 is 14y, and 24 multiplied by 7 is 168. Then looking at the second equation, if we want to make 7y into 14y, we're going to have to multiply by 2. So 4x multiplied by 2 is 8x. Then 7y multiplied by 2 is 14y. And 3 multiplied by 2 is 6. Now we have a 14y term in each, and because they're both positive, we're going to subtract the equations to eliminate this term. So 35x subtract 8x is 27x. Then 14y subtract 14y is 0. And 168 subtract 6 is 162. And then to solve, we divide by 27, which gives us x equals 6. Now we substitute into one of the equations we started with. Both look fairly similar this time, so I'm going to choose to substitute into the second equation. So now replacing x with 6, 4x becomes 4 multiplied by 6, which is 24. And we have add 7y equals 3. And then solving, we subtract 24 from each side to give us 7y equals negative 21. And then dividing by 7 gives us y equals negative 3. So our final answer is x equals 6 and y equals negative 3. So much for watching this Now Maths video. If you found this helpful, please like and subscribe if you can, and we'll see you next time.